Hey, so good morning everyone, and yes, so second up in the morning, which I think is slightly better than straight after the conference dinner. So I'm from the University of Oxford, but I'm representing here the EGI. You may have remember us from the grid and from supporting CERN, for example, in the discovery of the Higgs boson. I'm going to go through why we've decided that we're going to have to move into the cloud, what we're doing to actually make that happen, and then more importantly, who are the researchers and the research communities that we're actually going to be able to support by doing this. Because we've been accused in the past of being, I think, very narrowly focused, and here we show a true breadth in who we're able to work with and who we're able to support. So why? Well, the first one, of course, is in terms of academic e-infrastructure is the possibility of the growth of providers. With the grid infrastructure, of course, this was almost exclusively academic providers. We've now got people coming along as e-infrastructure, making e-infrastructure available in an incredibly wide and disparate way. We've got cloud providers coming along with the infrastructures and scales that we could never really be thinking about previously. How do we actually translate from our communities using their small clusters onto large data center scale sets of resources? From the user point of view, we've incredibly successfully supported just a shade over 20,000 researchers in the European area. That's pretty good, that's not bad. But of course the problem is that there are millions of researchers in Europe that we actually need to be able to support. So our idea here is taking narrowly focused technology, what we've done previously, expanding it, being able to support multiple different types of tools so that we can bring all of the rest of these researchers on board. They have a huge number of different use cases, different models of utilization that we want to be able to support and that we should be able to support. So what have we been thinking about in terms of federation? What are our ways that we've decided that this is going to be a key success? The first one, unlike the grid, is from the outset the adoption of open standards. Luckily they existed. So from that point of view, they are there. We're technology independent. We're not going to mandate our resources, our resource providers and our communities use one particular technology or another, because we found that is incredibly limiting. And most importantly, I don't care where the resources come from. If somebody is able, through their resources, to support the open standards that we require at the interfaces and the policies, then absolutely brilliant. They can come on board, they can provide resources to my user communities. And we've already been doing this with some from public cloud providers. And then, of course, we do have this foundation in the grid infrastructure that we want to build on. We don't want really to be trying to rebuild and trying to reinvent the wheel, as it were. So we intend to incorporate all of this cloud infrastructure using the underlying services that we develop for the grid. So here is our architecture. We've got on the bottom here in the orange and green boxes the core platform, the core sets of services that are infrastructure independent. This is all of the things you'd expect, sort of accounting, monitoring, authentication and authorization, service discovery, as well as some of the softer services, help and support, security coordination, because of course we support multiple different communities who have multiple different expectations in what they're going to get out of a secure service. Above that, we have our cloud infrastructure platform. These are our cloud management frameworks, which are then exposed through a set of standard interfaces, both instance management or virtual machine management and storage. On the left-hand side are the important bits around collaboration. So actually, how do our user communities start to use these services as they're being built? And here you can see the interfaces that we've chosen, some of the standards. You may have heard of these before. So OCCI as the Open Cloud Computing Interface, CDMI, the Cloud Data Management Interface, OVF, Open Virtualization Format. All of this is about ensuring that when somebody chooses a cloud management stack as an infrastructure provider, they are able themselves to freely change how they provide the underlying service. For those of you that have been in this game for a while, you know, the popular cloud management frameworks of now are not going to be here in 5 years' time. You know, there will be different frameworks. There will be better solutions will have come up. We need to let our providers follow that trend. We need to ensure that we're not limiting. But where do our users come in? And the reality is actually that our users come into all three of those different platforms because our users are no longer just the end user community. We now are very able to support the supporters of communities, those that run services for other communities on an operational basis and make them available to end users. So we ourselves are also reducing our support burden by making sure that we only really talk to the experts within a community. But we need to make sure at the same time that our tools, for example, our collaboration tools, are fit for purpose for the breadth that we're going to get out of that. Just a quick one, you know, people talk about the adoption of open standards. Oh, you know, these standards aren't there, these standards aren't being used. Well, just to say that actually, you know, the open standards that we've chosen have been widely adopted within the private cloud management frameworks, and we've also been working with other providers to get the standards supported with them as well. From the point of view of where we've got to in Europe, well, we've got 12 countries that have got certified resources, 19 of them within those countries. The interesting thing being that, as I alluded to earlier, the resource providers now are somewhat disparate. We have national infrastructure providers in national services, we have institutional providers, and we have commercial public cloud providers. All of these are in there giving resource. This has also gathered quite a lot of interest on a global scale. We've already had discussions with partners from outside of the EU. Though some of these are historical long-term collaborators through EGI, but some of them are newer members, newer collaborators that we've been talking to. Just a quick one about utilisation. I'm sorry, the number I realised is right down at the bottom. So far, since we've launched the cloud, which was in May of this year, we've actually run about 200,000 VMs, which doesn't sound like a lot. Yeah, that's only 25 clouds, 200,000, that's not really very much. But the reality is we need to get out of the metric that's come in a lot of this of, oh, it's numbers of jobs. It's actually about what the services that people are doing with them that matter. One virtual machine that's recorded in this accounting, for example, may have been running for a couple of weeks and serviced a few thousand people because it's running some form of community-specific service. So it's a lot more about improving our accounting statistics. It's about improving our accounting methodologies as we go forward. So what do we do with this cloud once we've got it? You know, the lowest level building block is where we are at the moment about our federated infrastructure as a service and federated storage as a service. What we now need to do and are doing is work with various communities about how they can introduce their own platforms onto this cloud, how they can manage those as infrastructure themselves, how we can also engage with different user communities and make perhaps some of these higher level services available ourselves. I highlight here, for example, database as a service or the Hadoop as a service as a sort of, you know, that's a fairly low level platform still. Next to that, we talk about secure storage, so doing the improvement on some of the more commercial storage services that are available. So Garbox, for example, that's been developed by our Italian collaborators, is a secure, capable Dropbox service that runs in public cloud systems in Italy. There's no reason why that technology can't be rolled out more widely around some of our other facilities. And finally then, what about those communities that really don't care about ICT at all? That actually just want to use software as a service, and perhaps use software as a service in a way such as, for example, here, what I've talked, the virtual e-laboratory. So laboratory information management systems, laboratory data collection systems, but things that they just want to see the software, the end user software, but they still want the flexibility and the availability that cloud services give them. So one of the bits within the more popular public clouds, of course, that's very important is how do people share, how do people upload their virtual machine instances into the cloud? We've been extending the EGI applications database into our virtual appliance catalogue. The idea being here that in very much the same way that there's a lot of conversations about open data, that there's actually a lot of conversations also about how we can share computational services, how we can share applications, how we can deliver those across and between communities. So we've been extending our AppDB to give it the capability where people are able to register their virtual machines, say actually how it's going to be shared, define where it's going to be uploaded once they've used it, and presented that to a particular user community. So connected that into some of the authentication and authorization that we have available, as well as some of the accounting and information publishing. So where are our user communities at the moment? The great thing is, everyone used to say the grid was just about high energy physics. Well, I have to say the high energy physicists are still here. They're just right down the bottom. We've got ecologists, linguists, software engineers, musicologists, geology, earth observation. All of these guys are using massively different models, and I'm going to highlight a few of those now as we go forward. But most importantly is actually people that come along with really different ways of using this infrastructure. And I particularly want to highlight these guys up here. So Cranfield University is a fairly well-known university in the UK, and it has a fairly well-respected computer science course and does a lot of distributed systems work. And one of the things that they came along to us and said is, well, we have a requirement for some infrastructure. We've in the past, used some private cloud resources. We don't want to carry on doing that because we've expanded the course. Can we use the Federated cloud to actually support our teaching? So this is going outside of just research support and research infrastructure to actually look at how it can be used by other communities. And this breakthrough into teaching is, in my mind, a very important thing, because it becomes, at the point where it's a service for research, your availability and reliability, yes, it has to be very good, but if it's not there, it's something that people can get round. If it's part of somebody's taught course, then the level of availability and reliability needs to be an awful lot better. When 40 students turn up for their lab and want to do it, and they've got exams and it's part of a structured thing, it needs to be there. But also, you can see here, beyond them, just to say, the other guys that came along since May of this year, they include some of Stephen's collaborators in Elixir. They include some national cloud projects who are branching out of just resources that they originally had within their projects. So what are people doing? Well, WNMR, so this is a nuclear magnetic resonance structural biology collaboration, and here they're actually distributing computational processing units within the cloud, within 3 different clouds, across Spain, Germany, and the Czech Republic. That's, that's fairly, that seems fairly grid-like still as a community. Yes?
5 minutes.
Yep. Helix Nebula, the European Space Agency. Here they're creating and distributing their own platforms within the cloud. So here they create virtual clusters, distribute them, connect them into their infrastructure, connect them into their resources as if they were local systems. The ISCAT 3D guys have developed through the ENVRI European Strategic Framework Project their own platform as a service computational infrastructure, and here, rather than distributing to public clouds, which was their original intention, they're actually looking at distributing it into a European federated cloud infrastructure. Peachnote. These guys are really interesting. This is a commercial company. So I want to make this very clear that, we talked about being provider agnostic, we're consumer agnostic now as well. These are guys, this is a small SME that's doing commercial musicology, so music score analysis, and they're doing this on the federated cloud. Important capabilities that we had to make sure were available to them is they have licensed software, and because they're commercial, they of course want to have encrypted data that's actually moved around and very secure end resources. So from that point of view, this was increased capability that we needed to make sure was on board. BioVal. These guys looking at the distribution of both the underlying computational resources, but also the controlling services. So moving all of their infrastructure into the cloud system. That's workflow engines, that's data management, that's processing systems. And they're able to do that both within a single cloud within the Federation and also across multiple clouds within the Federation. And finally, from my users, I recognize I'm running out of time, the Chain-Reds collaboration from Catania, or led by Catania, looking at the distribution of some open source software packages as platforms for various different research communities. And an important thing here is their Science Gateway is running again in the cloud, but also that we're not the only federation in town. This is a very important thing. There are other federations. There's the Chain-Reds have their own. There is the Helix Nebula Consortia as well. And an important thing that we need to make sure as we move forward is that we actually look how, we're not going to have only one federation. We need to work out how our user communities can use multiple systems like this. Here's just an illustration of how, they use the Italian Chain-Reds, which is down the bottom, with all of our different providers within the federated cloud, the EGI federated cloud. So where are we going? What are we trying to do in our technology evolution? The one that I'm going to really pick on here is about the support for open standards. And when I say, open standards for commercial cloud frameworks, I'll also say, we already have in beta prototype now an OCCI interface for Amazon. We're already working with other other commercial public cloud providers to get them to support open standards as well. So from that point of view, it is incredibly important. We do see a growth for this. It's about value-add services for the user. It's about strengthening the underpinning platform. It's about technology and user communities. So just to finish off, because I've got about 1 minute left, I reckon. It is a federation of, institutional, private, public clouds offering a single service. It's got to be able to scale. We are doing this in a manner rather than one big cloud. We actually want to do this through multiple smaller clouds. We're ensuring that we are based on open standards because that's one of the ways that A, we can be technology agnostic, B, we can be provider agnostic. But it's also a way that we're really pushing forward in a global way to create or connect these services. With interest from the United States, Australia, South Africa, Taiwan, Korea, Japan, all of these communities are coming and looking at this as a leadership example. And just to say where we are in capacity at the moment, We're at the 6,000 cores and a few hundred terabytes of storage. We've already got commitments to take us up to 6 petabytes of storage and 18,000 cores. But we have a very, very ambitious goal by 2020 to get us to 1 million cores and an exabyte of connected storage. And that's not through connecting a big single public cloud provider. That's about actually connecting more and more resources from across the different communities that we already have. I'd like to end by thanking my community. These are the guys that actually do all of the work, that actually bring it all together, that make the federated cloud actually work. I stand up here and talk about it, but these are the chaps that actually do it. So I'd like to thank them, and then thank you. And are there any questions?
Thank you very much. Excellent timing. Any questions? I had one.
Yes.
And maybe I was a bit dozy and missed it. What's the business model linked to providing this infrastructure to commercial organisations? Or who pays what in the system?
Well, so the aim is actually that we'll be able to support multiple different business models, that we'll be able to support user communities that have resources, so public user resources. But Peachnote, for example, are already working with one of our public cloud providers to look at an underlying pay-per-use structure. EGI itself is also working on a pay-per-use formula for different communities. Because one of the things I'd say actually that if you go out there and ask honestly of all of the research communities, at the moment the largest provider of e-infrastructure in Europe is undoubtedly Amazon. And so people are already paying for it. So we've just got to get our resource providers able to accept it, and also our user communities to acknowledge more publicly that they are also paying for it already.
Okay.
When you're mentioning, David, that Amazon has quite a market dominance, wouldn't it be good to provide some sort of EC2 interfacing to the EGI Federated Cloud so that you could perhaps attract some of these customers?
So absolutely. Is that EC2 from last week? Is that EC2 from 2 weeks ago? Is that EC2 from 3 months ago? Because EC2 had 147 different updates last year. Apache, through their cloud stack, released 3 consecutive versions with broken EC2 support because they weren't able to keep up with Amazon's development rate. We're talking to Amazon actually at the moment, and this was one of the things that we pointed out to them, was that, if you're going to have a development rate like that, you actually need to do versioning, and you need to do some form of backward compatibility because of the investment that people make in both time and money into tools and services that connect to it. But actually, I think the danger with EC2 is still, if you actually start supporting EC2, what about all the other communities? What about all the other public cloud providers? There are about 70 small to medium public cloud providers in Europe. Many of them either support different interfaces. Some of them support EC2. Some of them support open standards already, both our own open standard, both OCCI or the DMTF semi-open standard. I think, to be honest, I would like to say that the reason we support open standards overall is that, I don't want to favour one public cloud provider over any other. Yes, there's been some investment, but also, the reality is that the difference in these interfaces is, they're all REST-based interfaces. There are very small changes, and so the investment needed to change from one interface to another, unless you're using some of the very higher value-add services on top, which are not going to be available anywhere else, is actually pretty small.
Okay. Thank you again, David, for your presentation.
Thank you.